Good morning students. Today I will discuss about the design of footing. Let us look at the steps first. Step number 1. The load on the RCC column will be given. Let us denote it as W. Step number 2. Factored load, that is W subscript F. Factored load is equal to W into FOS, that is the factor of safety. This is the second step. The third step is the bearing capacity of the soil is denoted as small q. It will also be given in the question. Fourth step, that is the area of the footing. How you have to find the area of the footing? Area of the footing is equal to factored load divided by the bearing capacity, that is WF by Q. The fifth step or the last step, how we will find the side of a footing. Number 1, if it is a square footing, if you assume it, so the side is equal to under root of A because the area of a square is equal to B square. Or the second option, if it is a circular footing, then you have to find the diameter of the footing. The diameter will be equal to under root of 4A by pi, because you know that the area of a circle is equal to pi by 4 d square. Next we will discuss about one gate question, that how to solve the design of the footing or find the side of a footing. Let us see past gate question. The load on a RCC column is 150 kilonewton. The soil bearing capacity is 80 kilonewton per meter square. Assuming a factor of safety of 1.2, the side of the square column footing is dash meter within bracket rounded off to 1 decimal place. Okay, now let us see that how to solve the problem. Load on the RCC column is given as 150 kilonewton, so capital W is equal to 150 kilonewton. Factor of safety FOS is given as 1.2. So what will be the factored load? The factored load will be WF equal to FOS into W, that is 150 into 1.2 kilonewton. The soil bearing capacity small q is given as 80 kilonewton per meter square. So as per our previous slide, that is the area of the footing is given as capital A is equal to WF by Q, that is the factored load divided by the soil bearing capacity. So 150 into 1.2 divided by 80, that gives us 2.25 meters square area of the footing. So how we will find the side of the footing? Here in the question it is given as that assume as a square footing. So the side of a square footing will be small b equal to under root of A, that is under root of 2.25, which gives us 1.5 meter. Let us see another gate question on footing. The live load and dead load in a 3-storied residential building transferred through a single column is 12 tons and 15 tons respectively. If the soil bearing capacity is 10 ton square meter and the factor of safety is 1.5, the area of the column footing is square meter within bracket up to 1 decimal place. Let us see how to solve the problem. Here live load is given as 12 tons, dead load is given as 18 tons, FOS factor of safety is given as 1.5 and the soil bearing capacity is given as 10 ton per meter square. So first we have written down all the data, correct? Now what will be the total load? The total load is live load plus dead load, that is 12 plus 18, that is 30 tons. What will be the factored load? Factored load will be FOS into the W, that is 1.5 into 30. So what will be the area of the footing? The area of the footing will be WF by Q, that is the factored load divided by the soil bearing capacity. So 1.5 into 30 divided by 10, which gives us as 4.5 meters square. As you have seen in the last problem, they have asked for the side of the footing, but here they have asked only for the area of the footing.